Right, so I think the first thing we should do, I should just present the GitHub page. Right, so I put this up on my GitHub for the moment, at least. So I've basically put instructions about how to put a Pi 0 onto a UKMARSBot. So I've got, you know, basically, if you come down the bottom, there's a set of sub pages, right? So there's some calculations about the power. These options for communicating, which gives you what sort of options you've got, and then there's some diagrams about how to connect the two. What needs connecting. Stuff about how to install the OS and then how to log into the Pi and what sort of things you need to change. So specifically, I've set the Raspberry Pi up to be OTG configuration, which means you can basically plug the USB into a computer and use it as a serial interface. So rather than trying to connect a monitor and a keyboard, you just connect the Pi 0 is unique in the fact it can act as in on-the-go mode. So you can sort of directly log into the Raspberry Pi over a USB cable. That's important for two reasons. One is obviously connecting a keyboard and a monitor to your mouse is not ideal. The second one is that we're using the normal serial port to communicate with the Nano. So that's not an option either. Now, I have done because we're running the Pi off the Arduino regulator, and that's we have to be careful about the current draw. So you can get the Pi 0 down to about 80 milliamps. So if you work that out in watts and all that sort of stuff, it looks like it's got some clearance on the standard like Arduino Nano version 3s, and also the standard clones from people like Elegoo. Obviously, if you're using a random clone, then you've got the problem that if they put a rubbish 5-volt regulator on, then you can either easily exceed the power requirements. I had a look for the Pi 0 W, the one with the Wi-Fi and the Bluetooth on board. I need to finish the calculations for that. It looks much closer to the bone on the regulator power. So I thought, well, I'll start with the basic Pi 0 to start with. What else have I got? I've got you need to disable the debug because normally that UART's used for the Linux debug console. I've actually got. I've started a bit of the. So what I was using was I'd taken Pete's tests and put them in a project. This was a few months ago, and added a command line interpreter on the top, so I could run all Pete's hardware tests, but inside a command line interpreter. So and that was relatively minimal. So I'd started to use that as sort of the I/O process. Obviously, there needs to be a bunch more work on the firmware. I also knocked up over the weekend. I knocked up a mount to put this. Now, what I did was modify the motor mount. So I looked at various options. Obviously, Pete's wonderful hardware design wasn't really designed to put both a Nano and a Pi 0 on at the same time, but that didn't stop me. So this connects here. So I've effectively put 2 extra holes in this motor mount, and then I put nylon 2.5mm nylon screws. I didn't even actually tap this this. They just friction fit is good enough on my first attempt, which is the first time ever in about 10 years of designing bits of plastic and 30 years of being involved. My experience is it never works first time. This, for some reason, did. And then I used the 2mm. I used some 2mm bolts, just 9mm long, to just friction fit onto these, and it feels quite robust. We'll have to see once it hits a few walls. And from the side, it looks like this. So it actually, you can fit, as you can see with the Nano, you can actually fit a mini USB cable underneath without having to disassemble this whole mechanical assembly. I actually can fit a mini USB cable underneath if I need to. I don't think I've got a picture of the latest wiring on here. I've got a photo somewhere. I've actually got a wiring loom that runs from here over the Raspberry Pi and then down to this connector. There's actually an extra. I fitted an extra. This is a strap. Maybe I can find a photo in a second. But I fitted a 5th cable. So the original 4 cables were power, 5 volts, ground, TX and RX. Oh, in fact, I can show you this in the. And then I actually fitted, to test it, I fitted an extra cable to the reset line of the Arduino Nano with a Schottky, which is probably enough. I mean, I've got some level converters somewhere. So what else have I done? So that's the mechanical mount. I've done the. I've started a page for the software. It's not finished for the Pi Zero. I've actually got some code. I can probably talk about that in a minute. We also obviously need to shut down the Pi Zero, ideally with the switches on the back of the board. So, get the Pi to talk to the Arduino to patch up the switch data. And I've also got a few scratch pages I've started with to probably collect information from elsewhere. For instance, the more detailed information on reducing the power consumption, information about using a Pi W, the implications of that. Programming the Nano from the Pi Zero should be possible as long as you've got a reset line. Not necessary. I mean, you can just disconnect the cable and put a mini USB into the Nano underneath. Boot time, real-time processing, which is from previous presentation I want to include. And then I also got some notes. This was from our conversation previously in about the fact that we could probably replace the Arduino Nano entirely. I've got a bunch of notes on that I'd like to include. So if I go back to this few pages of this presentation, so this is sort of my still to-do list. So I want to run some more tests about. I'll probably run. There was a reason why I thought I needed to run it. Normally, I'll run these. In fact, on when I put a Pi on Ken's stepper, I ran it at 57K. The reason for that was the accuracy of the UARTs at higher baud rate. I think on the that was the older DS PIC. So I don't know whether it's going to be 38K, 57K, or 150K. I need to do some calculations about that, and also have a look at the sort of the system latency, because I think that's going to decide, make some effect on the split between the Pi and the Nano. Obviously, we want to. I think I've got some notes about that in a minute, but obviously, the more we drive up to the Pi, the better. I think that means that.
Can I
go ahead.
Can you just try? That's better. It's gone. Whatever you did, it's done it now. Something was obscuring part of your slides, but it's gone.
Oh. Okay. Yeah. So I might need to tweak this command line interpreter I've got. I might need to tweak that based on now because I've got both the stepper mouse, Ken's stepper mouse with a Pi on, which is referred to as Dizzy, and also the line follower I built with the Vision with the GoPi Go robot. Both of those are split architecture robots. So I've done this to a certain extent before, but I think that requires a bit of playing about with, which I haven't done. And then obviously we want some basic software on the Pi, maybe a line follower or a wall follower. Give people something to do with the maze solver. So that's sort of my list of things still to do. I've talked about that already. So I'm not sure. I haven't got around to emailing the mailing list yet. So that's probably something I should do over the next few days. And I'm not sure, Ian, what you'd planned. I know it'd be advantageous for us to have a Raspberry Pi base design, and I know who's got sort of time to work on this.
Plans much too strong a word here, Rob. It was a thought going through my head, which was we have UKMARSBOT. It's a good starting point robot, but a lot of the schools were focusing on Pi.
Yeah,
that's where a lot of the focus was. So it was literally, can we use the UKMARSBOT as a platform to mount a Pi on? And originally my thought was, which is where you've gone with it, which is just put a serial link in between the Pi and the Nano and present to the Pi. And we talked about a very similar topic, like having the Lego type interface to the UKMARSBOT in the past. So something like that, which would talk over and so that's as far as it went, Rob. Although I must admit, over Christmas, I did get, apart from my real Raspberry Pi, I actually got a Raspberry Pi in to start playing with it. But it's so far it's basically been in and run up and made sure it works. But I bow to the people that do more work with the schools. But it struck me that if we could offer a platform that was programmable on Pi, so maybe we gave firmware in the Arduino to do all the nasty grubby bits with the I/O. We would have an opportunity for people to build things for Pi walls or whatever built on UKMARSBOT. So that.
Yeah, I mean, that's what the PiGo Pi, which was a Kickstarter, I don't know, 5-6 years ago, they had I don't know if it's not AVR or what it was, but they had sort of an I/O processor at the bottom to help them do it. I know I've certainly seen even drones running with just Raspberry Pis in them, but it sort of makes things a bit harder if you haven't got some sort of basic I/O to do all the fast stuff.
Yeah.
So, I mean, to me, it seems, based on my previous playing with this, it seems relatively easy. I mean, you're talking about, 3D printing 3 parts, and then you're talking about 4 wires and 2 resistors. So it's about as minimal a change to the UKMARSBOT as you could get in terms of hardware. And so I think, I mean, certainly what I'll do, I've basically switched on to this for the moment. And what I'll do is I'll run some tests and see if I can get a demo of it running about, driven by the Pi, and I'll push everything up to the GitHub page anyway. Right. I mean, my last slide was about debugging. What we need to be able to do is allow people to sort of get it running as even maybe as a reasonable maze solver. So we probably need to provide some tools for people to figure out what's going wrong. I mean, one of the problems you get on these sort of 2 micro designs, even if you've got the source code to both, is the communication is obviously dependent on the real-time stuff. So it's sometimes tricky to know when things go wrong, exactly which bit's responsible for it crashing. Whereas if you've got a single micro, then effectively everything's under that one thing. So one of the things we might want to do is give it, I mean, it's possible, for instance, for you to write quite a large log files to the to the RAM. You don't necessarily want to write anything to SD card, because with these single core chips, it tends to kill your real-time response. That was the biggest thing I saw on Dizzy, the stepper with the Pi Zero. Whereas if I didn't touch the SD card at all, I was getting pretty good real-time responses. So we might want to provide some tools for capturing all of that, and then when the run's finished, saving it to a file for analysis.
Yeah,
So
I must admit that's quite a lot more sophisticated than I was going in my head initially, because the Pi Wars challenges tend to be sort of a bit different to that. David knows more than I do about that, but I mean, for example, quite a few of them are remote control type stuff, which I would have thought would work quite well, because you get the Pi controller talking to the Pi, and the Pi tells the subsystem what to do.
Is it possible for somebody to write up a list of challenges or features they'd like to see in the base? You know, what's the minimum to compete in this as a Pi robot in some of these sort of things? I mean, getting somebody to write some of that stuff up, David or Ian. I mean, that might help us guide what's the minimum we need to do.
Yeah, I think it's a good thought. David, what do you think?
I could certainly write up a bit about the sorts of things that you'd need to be able to do. Sorry, can you hear me? I'm on maximum volume.
Yeah, I can now.
Okay, yeah. I could write up the sorts of functionality that you need to be able to address the typical Pi Wars challenges. They do change every year, but they're similar enough that a specification would cover most of them. The only thing that in general is that most Pi Wars robots are bigger than UKMARSBOT, because you end up sort of going over obstacles and things like that. So there might be some issues there, but maybe we can get around that by just sticking bigger wheels on it.
It's quite a lot of clearance underneath. I don't know whether there's enough, but David, I mean, even maybe getting some specifications about what sort of clearance they've got to make. I mean, I think it'd be useful having a Pi. Whenever I talk to my kids, they're always more interested in the Raspberry Pi side of things. And I know my daughter's done a bit on Arduino. She was doing it's a long story. She was doing a Halloween costume before we got locked down. And there's a game called Being Human. They've got a LED display on the side of their heads as the droids. So she was doing that with an Arduino, but a lot of them want to play with Raspberry Pis.
So is the point of this to get the MarsBot into Raspberry Wars or whatever it is, or is the point of this to get the people who are moving to Raspberry Wars because they need to do Raspberry Pi stuff into our competitions? And I think those are two different things.
Don't care. It's my view. It's, do we get more people building robots is about my only
I think one of the things that drives it is the fact that most schools, when they're doing their computing GCSEs or whatever they are that they're doing, tend to be using Raspberry Pis these days. So that will be the sort of preferred platform for things that they will be interested in and want to know about. So if you've got something that is Raspberry Pi based, then you've got probably a better chance of getting them interested in it and doing things which will not only be good for us, but will actually be good for them, because that will help them to develop their Raspberry Pi skills.
It to be good for them, but I think what we don't want to be doing is trying to redesign the MarsBot so that it can go over rough terrain, because that's what their competition is.
I mean,
so what do people use to actually program up the Pis typically? Is it visual on-screen stuff, or Python, or what?
Python tends to be the language that's in favor in the schools these days.
So then,
so it tends to be that most of the stuff that they're writing is Python.
But it seems to me the most obvious way to run a MarsBot from a Pi is over the serial link with some kind of human readable and human generatable command, so that you could, if you wished, connect up a Bluetooth module and type stuff into a terminal and have the exact same effect as if the Pi were driving it.
Yeah,
and
that
generate
was
the serial
what
commands from Python is easy.
Yeah, so I mean, my DZ, the stepper mouse that I put a Pi 0 onto and a camera, the Pi code was actually in Python, and then, but the protocol, I need to double check, but I think it had some binary components, and the reason I took the command line interpreter I put on top of your test code, Pete, on this was that you could just type it in from a, it was, you put like L1 and it would turn on one of the legs, and you put M1 and it would turn on a motor test, and you put, so it was very terse. So you weren't using a lot, you weren't ending up with a lot of latency on the connection, but conversely, you could actually type it in from a serial terminal. Hence why I thought
in the style of G code or something like that, right? So it doesn't have to be great big long words, just something that tells it what to do.
Exactly. So that's why I took the command line interpreter from my project Marzi, and just started that as a starting point. My plan was to put a branch on that, and then add some commands as I got into the testing. But obviously, you'd want to do this. Certainly, you want to do the speed control in the Nano. Now, I can't remember on Dizzy it did speed and acceleration control, but I think I was doing some of the position control, the coarse position control on the stepper mouse from Python. So, I mean, as long as you make sure that Python's the only thing that's running, it runs pretty fast on that Broadcom chip. So I didn't really have any real-time problems. So I was planning on sort of reproducing some of that previous architecture on this, which also gives you a large amount of control on this design just from the Pi. So that, I don't know if you can see that. That's the picture of the board strapped to with the wires. And I put a bit of heat shrink on it. So it's I don't know. It's relatively neat and easy to do. You don't need the blue wire, as I said. That blue wire is the reset line. I wanted to try. While I was there, I actually glued it on yesterday and heat shrinked it in. And actually, because I need a connector, because there's no. That's one of the things on that header, Pete. On version, whatever the next version of the board is, we should probably make that connector a 5-pin header and add reset as one of the lines.
Passing through the reset is always a bit of a pain. Pretty much every Arduino Uno daughter board, shield, whatever, passes through the reset, presumably because things get hairy and you have to reset the damn thing. So yeah, give some thought to that. I'm loath to put any more stuff on that.
Yeah.
Pin connector.
So what I did was I soldered it. I soldered it because we hadn't connected anything on the Arduino. We hadn't connected anything to pin 3. It's not pin 3. 3 down from the right hand side. So I just soldered a Schottky diode on the bottom, fed it through a hole, and formed it with a pair of pliers into a pin shape. I'll take a photo of that side if I might even have one somewhere, but anyway. So
okay, hang on, crazy idea. Just think about it whilst you're playing with your 3D printer. Underneath the mount for the Pi, protuberance which reaches down to the reset button. So you just press the entire Pi down and reset it.
Well, the thing I was thinking about, Pete, was that if the Pi had control of that reset button, then theoretically we could program the Arduino from the Pi.
Oh, I see.
I mean, it's not mandatory, right? You can plug a lead in and just reprogram it with what's it called? But it sort of reduces the amount of dev kit you need.
Okay.
Right? If we include like an Arduino programmer with it, then all you need to do is reprogram the Pi, and you effectively.
But the Arduino, the Nano's got a bootloader on it, so
yeah, you can program it over serial.
Yeah, I mean,
this is all. I mean, any ideas at all, guys?
Because
I'm just making this stuff up as I go.
I can
Can I
tell.
throw
So
something?
if
Right.
so, all right, it's an interesting idea, but not, I would suggest, in the early steps.
Agreed.
Can I throw a question in? Well, looking at the picture, it looks like the Pi is sitting over the front sensor board.
Let
Is
me
that
just
correct?
see if I can find a side picture. This one, maybe?
I just pointed to it. Idiot thing.
Sadly, we haven't got touch screens that are remote.
You got it though.
So it's sitting over the front. I'm just thinking that the mouse is already front heavy. Could the extension on the motor mounts go back rather than forwards, so that the extra weight is over the back, over the battery, and that would level up the weight?
Yeah, well, I mean, my open SCAD files are on the GitHub page. I mean, if somebody else wants to knock up a 3D design, I'll print it and try it out.
All right.
So it could just sit like up over there.
Yeah, that's what I was thinking.
Yeah.
Because, say, with adding more weight on the front, we're just making it even more front heavy. And at the moment, the front skid is running along the ground, and it's going to be pushing down even more at the moment with that on the front.
Yeah. I mean, as I said, I only knocked it up on Sunday just to have something for this meeting. Just in time engineering.
It's good.
Rob, because you were far further forward than I was expecting when I just sort of threw this thing in and said, oh no, I've done a bit of work on that, and then this page popped up with all this stuff on. I think what we've got is, David, I'm happy to work with you as well on the Pi. What capabilities? What are we looking for out of this?
Yeah.
And then I think we should probably invite anybody who wants to get involved in doing. There's a little bit of an element of a solution looking for a problem here, I have to confess. But I do think
it gives us an extra option, doesn't it, Ian? In my opinion, it gives us an extra option.
Can you hear me on this thing? Can you hear me? Okay.
Yeah.
I'd like to go and get another microphone. I've been shouting at you for the last 20 minutes. Yeah. One of the things that concerns me is if you're trying to run this software in both processors, there's a whole load of possibilities of bugs. And the thing about using a Raspberry Pi is I think the kids are going to want to use the features of a Raspberry Pi. And some of those are going to mess up your real-time performance. Have you considered running it as a sort of compiler? So you take your bit of Python or whatever, and you pass it through some kind of processor and actually run it in the Arduino, just sending data back up to the Pi to tell the Pi where everything is?
I think silence probably means no. It's the short answer.
I think you need to be a bit more specific with me, Duncan.
Yeah, I think that's exactly what's being proposed.
Yeah, I mean, all I was planning on DZ, right, my stepper mouse with the Raspberry Pi, all that the Arduino effectively does is acts as an I/O processor. So apart from some very fast stuff, all I want it to do really is be able to read and write, right? I'm not worried about the speed of Python, to be honest, Duncan, or any high-level language, right? But I want the Arduino to be as almost nothing, right? But you get some places, like if you're doing maybe speed control, that I'm not sure that, unless you're running at a high enough baud rate. So I did consider using SPI or something. You're never going to be able to get a sub-millisecond. Anything sub-millisecond needs to be done on the Arduino.
Yeah.
I
Anything,
don't do it on the Arduino either, actually.
yeah, I was going to say, but anything above a millisecond, right? I've seen the Pi has no problem, even with Python, running in the millisecond domain. Right now, you can always add either Forth or C or C++ or whatever you want on the Pi Zero side. And in fact, on the Dizzy, which got camera on, the vision processor was a piece of C code. Right, it wasn't done in Python. But so I think the idea, I don't know that's what you're saying, Duncan. From my point of view, we should put as much, the least amount we can get away with on the Arduino.
Yeah,
The
but
Arduino just had.
what you were saying was that when you went away to write the SD card, the real-time performance of the Pi fell apart.
Yeah.
Now, it's things like writing the SD card that the kids might very well do.
So what my suggestion is, we have an example of how to do that. So all we need to do is hold off, because it's got half a gig of RAM. Just buffer up. I mean, you've got a massive amount of RAM, and especially if you're not running it in graphical mode, you can just allocate 8 or 16 meg to the graphics chip, right, to provide a frame buffer, and then you can write 100 megabytes a day data into RAM. And then just when you're finished, write all of that back to SD card.
I think we're jumping the gun here a bit, guys. In the sense that the idea of having the Pi do real-time control of the robot is a step beyond, when it would be perfectly possible to have a simpler interface which says to the robot, either run these two wheels at these speeds, or run with this angular velocity or that forward speed, and have it control that, right? And that aspect of the real-time control has got nothing to do with the Pi. The Pi just says run at 1 meter per second, in the sure and certain knowledge that the robot will do as it's told. And then the only two, off the top of my head, the only two kinds of real-time interaction that you might require is to read the sensors, which can be done quickly, okay, and then make a decision. And those decisions are not instantaneous decisions. They're not real-time control decisions. They may not even be steering control decisions. They may be, you better get ready to turn left, right? Or in another 50 millimeters, I need you to stop, or something like that.
Yeah, but I think you need to be able to download the wall following or the line following down into the Arduino.
I don't think so.
No, I think
Right, so I think we're all getting into architecture without some actual tests.
yeah. Well,
And although I've done some of this stuff before, I'm a bit nervous about being overly prescriptive, and I think different people are going to have different approaches to this as well, Duncan. Right? I mean, we know definitely the people on this call will approach the problem differently.
Oh,
right?
yeah.
So I think what we want is some minimal stuff that people can expand out from. If you just, if you're 12 and want to play with a Pi and get something moving about, that the rest of us can hack the code and do alternative architectures. But until something's up and running, it's tricky to propose alternatives and to do tests to see what actually works.
yeah, Rob. Sorry, I mean, I was trying to keep it relatively simple initially, because I think that's what works, and that's what's going to happen. And my vision was that we would retain to the Arduino, move me at whatever speed, or move me with this speed and this angular velocity.
Yeah.
So that kind of level of instruction, and then you're taking supervisory decisions over that off on the Pi, and that was kind of where my head was. So we probably need to take stock with input from David about the type of challenges we need to argue, and then probably put something up. Now, I'm happy to work with you, and if somebody else wants to volunteer to be on that, and we just put up some kind of straw man and say, this is what we think we'll build, and maybe even build it with a really simple interface on it. And then we can shoot it down if we need to. But I think if we can just give someone the basics that says, I can write a piece of Python that will get this mouse to move, turn left, turn right, spin on the spot.
So how about that we can get a discussion document up on the UKMARS site as a blog post, and then people can comment upon it, or we can talk about it at a future meeting or whatever?
Yeah. I think that would be a good place to go with this now. So, Rob, first of all, thanks very much for talking to us and updating us with this stuff. And for the stuff, I've got a few questions for you about the 0W, which would have been my preferred. I understand the power constraints on it. I think there are some UART changes as well that you need to consider for the 0W, because it talks to the onboard.
Yeah, I mean, you should probably have a look at just the first document on this power calculations, and have a look at it's not actually all that many milliamps extra, or many milliwatts extra for the Pi 0W. But I thought I'd start with the Pi 0 and check that would actually there was a sufficient overhead in the regulator. I mean, I don't know either for the Arduino, the original Arduino design, or the clones, how much heat sinks are on those 1117s.
You've got about 90 milliamps to play with.
What's that?
Typically about 90 milliamps spare from an Arduino Nano.
Yeah. So, I mean, those... Yeah. So that means we're running it probably at the... If your calculations are correct, Pete, then we're probably running it with a Pi 0 about the limit, and then a Pi W is going to take us about, I don't know, can't remember, but I've got some figures actually on this.
Okay, that's fine. We just have to figure out
about 20 or 30 milliamps more than that.
Yeah.
Yeah, so the standard idling 0 is 100 milliamps, but you can get that down to 80 by disabling the HDMI. Right. And then a 0W, they reckon it's about 120.
Okay.
Now obviously, well, it's significant if you load it up 100% processor usage, then it pulls a few more milliamps in. But
okay,
is that while using things like Wi-Fi though? Because all chips that I've seen that use Wi-Fi are, up in the 200 milliamp arena.
Yeah, so there's some
pulse.
Yes, I mean you might be better off disabling the Wi-Fi and just running it on Bluetooth, perhaps.
Can I just ask, the UKMARSBOT runs off a 9-volt battery, is that right?
Yeah.
Yep.
And the supply is a 5-volt supply?
Yeah.
So if you put in a series resistor, probably with a capacitor as well, that dropped 2 volts, so the supply to the regulator was actually 7 volts instead of 9, you could draw twice the current through it, because the dissipation would be dropped. You'd be dissipating in the resistor instead of the regulator.
You'd
have to patch the board up, of course, but yeah.
You also have to be careful with those 9-volt batteries, though. Some of them are, you'll end up being restricted by that rather than the regular.
Yeah, I mean, I think it's the version 3 nanos. I think they got a low dropout regulator, haven't they, Pete?
Yeah, they're good for an amp.
Yeah, but I mean, in terms of the minimum voltage you can run them at, it's about 6.3 volts or something.
Yeah.
As soon as you start to worry about whether or not the regulator will drop out, you're already in trouble.
Yeah, agreed.
I wouldn't be averse to running a back to the battery actually.
Anyway, I mean, that, I'll send out the link to the GitHub page. You can tear apart my power calculations.
Okay, Rob, thanks very much. Excellent stuff. I think we'll let that that blog emerge so we can comment on it. And anyone who wants to help volunteer with this stuff, then please come forward, because we can probably put something together on this if we've got a few people working on it.